Today we're moving on to a different equation, a different form of a linear equation. Up until this point we've been practicing our graphing of lines. We've been working on slope and y-intercept and y equals mx plus b intercept form equations. But today we're going to be introducing also the point-slope form and talking about when that is used. So let's just start off by remembering what is true of all linear equations. And this is true for other types of equations as well in the first category here, and that is that every linear equation has an x and y variable. Okay, so they have x and y variables. In other words, they have two variables. So the values of x and y are changing as we go along the line. And they will form a straight line when graphed. Later on this year, we'll be talking about quadratic equations and exponential equations and even absolute value equations that don't form a straight line when graphed, but linear equations, of course, the word linear comes from the word line, and we're talking about straight line. Remember, the intercept form is the one that we've been using. So that's the y equals mx plus b, where the x and y stay in the equation, but we put numbers in place of the m and in place of the b. And in place of the m, we'll put a number in that will stand for the slope, in other words, the rise over run value, the rate of change for our line. And the b term will be a point on the line. The b term specifically is the y-intercept point on the line. So if that was a value of 5 here, if it was plus 5, we would know the line would cross the y-axis at a value of 5. So we would use that along with the slope to graph the line. Now, in this section, we're going to be talking about another form, so still of a line, but it's called the point-slope form. And the equation will look something like this. You'll have y minus y sub 1 equals m times parentheses x minus x sub 1. Now, it has some similarities and differences to the intercept form. The point-slope form will still have the m value stand for the slope. So we're still using the slope. But instead of using the y-intercept point, this value here for y sub 1 and this value here for x sub 1, these two together will be a point on the line. So x1 comma y1 will be a point on the line, but not necessarily the y-intercept point. Okay, so there'll be numbers in these slots right here, there'll be a number here, there'll be a number here, and those numbers will be the x value and the y value for our point. Remember, the y-intercept point is, for instance, like 0, 5. So if this were a value of 5, it would be 0, comma 5. We sometimes just think of the y value for the y-intercept, but it does have an x value also. It has an x value of 0, 5. So this is similar in that if this was 6 and this number right here was like 4, then our point would be 6, comma 4. So the x value of the point would be the 6 and the y value would be the 4. So then we would use 6, 4 and then the slope to get to the next point, just like we start off with the y-intercept here and then use the slope to get to the next point. Okay? So let's do a few examples related to this. So the first example says, consider the line whose slope is 3/4 and the y-intercept is -7. So notice we've got the y-intercept is -7, so underline that. And we can also underline the slope is 3/4. So which form do we use? Well, if you have a y-intercept and you have a slope, you should be thinking about the intercept form, the one that we've been using all along, the y equals mx plus b. So intercept form, which again is y equals mx plus b. Right? If we've got the y-intercept and we've got the slope, then we still use the intercept form. So in this case, the equation would be, and you guys probably could tell me this, so our slope is 3/4, so I'll put that in front of x, and then our y-intercept is -7, so we're just going to say -7. All right, you could say plus -7. You could say 3/4 x plus -7 if you prefer, although typically we just say, instead of plus a negative, when you add a negative, that's the same thing as subtracting. So usually we're going to write the equation like that. So y equals 3/4 x minus 7. In number 2, it says, consider the line going through the point -1, 5 with a slope of 3. So in this case, notice we have a point, -1, 5, and we have a slope of 3. So instead of being given the y-intercept and the slope, we have a point and a slope, so that means that we're going to use the point-slope form. So that's the new form that we're learning today. So the point-slope form, which is y minus y sub 1 equals m times x minus x sub 1. All right? And remember, we're just going to put in numbers. So here's your x1 and your y1, and of course your slope is your m. So we're just going to put those numbers in the places in the equation. So we're going to take the y value for our point, and we'll put that y value in. So this y value here is 5. So we're going to put that in the y sub 1 spot. We're going to take the x value for a point. So our x value is -1. So that x sub 1, we'll replace that with -1. And then we have our slope, which is 3. So we'll take that and we'll put that in here. So that's basically the equation right there then. Y minus 5 equals 3 times x minus -1. Now I am going to just clean that up just slightly. So I'm just going to rewrite that here. So y minus 5 equals 3 times x. And instead of doing minus a negative, when you subtract a negative, remember, minusing a negative is really the same thing as adding. Those two symbols sort of merge together and become a plus sign. So this really is the better way of writing the equation. Instead of the minus, the -1, we write x plus 1. Okay? Now, that equation right there is the point-slope form. But we can do a little bit of work and transform it back into the intercept form. All right, so we can make this equation into a y equals mx plus b form, and so that's what we're going to do here. We're going to take that equation, the y minus 5 equals 3 times x plus 1, and we're going to do a little bit of algebra with it and just transform it back into our y equals mx plus b. We know when we have the number in front of the parentheses here that we can use the distributive property. So I'm just going to rewrite this equation then. So we've got y minus 5 equals, okay, 3 times x is 3x. 3 times 1 is 3, positive 3. So it's looking close now. We're almost into y equals mx plus b form. But we still have this y minus 5 over here. So if I want to get y by itself, because it's y equals mx plus b, so y has to be by itself, we'll undo the subtracting 5 by adding 5, and you'll be left with just y. And then we have 3x here, the like terms, 3 plus 5 would be 8. So now you've taken that equation, and this is the same equation, all right, but we've transformed it now into intercept form. So now we know, by looking at this, what the y-intercept is. We already knew that we had the point -1, 5 and a slope of 3. Notice my slope is still 3 because it's the same line. It can't have a different slope. But instead of looking at the y-intercept, actually instead of looking at this point -1, 5, now I have the y-intercept point of 8. Okay? So my y-intercept is 8. 0, 8 if you were writing the coordinates of the y-intercept, but the y-intercept, you might just say, is positive 8. Okay? So now we can go back and forth between these different forms. Number 3, consider the line going through the points 5, -8, and -4, 10. So we're going to write the equation of this line, or find the y-intercept point, by using the slope and one of the points. right? So first off, we have to get the slope. Remember our slope formula, you might just want to jot that over on the side here. The slope formula, remember, is you subtract the y values to get the rise, and you subtract the x values to get the run. Okay, this is our slope formula. We used that in the previous number of assignments and was on the quiz. So we're going to take the two y values and we're going to subtract them to get the slope. So 10 minus negative 8. That's our rise amount. And then our run amount is going to be the two x values subtracted. So second x minus the first x is going to be equal to 18 over, okay, by the way, 10 minus negative 8 is the same as 10 plus 8, so that's positive 18. Negative 4 minus 5, so you're negative and you're subtracting, so you're going down, and so that would be negative 9. And then we'll reduce that fraction, so 18 over negative 9 is the same as negative 2 over 1, or just negative 2. So your slope is negative 2. Let's now find the y-intercept. So we're going to take the point here. We're going to take the points, or one of the points, and plug that in to find the y-intercept. So we're going to repeat the process we did here in step number 2, or problem number 2. So let's just say we're going to use this point. You could use either point, but let's use the point 5, negative 8. All right? So we're going to use that point and that slope, right? And we're going to put it into our point slope form. So remember, here's our point slope form that we learned today. So we're going to put the point in. We're going to take that y value, and we're going to put in the y value for our point. So that was the negative 8. All right, so we're going to put negative 8 in that slot. We're going to take our slope, and we're going to put it in for m. And our slope we just figured out was negative 2. So we're going to put that slope in here. All right, so here's our slope right here, negative 2. And then we're going to take the x value for our point. We're going to put that in place of the x. So our x value for our point over here is 5. So we're going to put that in this spot. Okay. And so we basically have the point slope form then. The only thing that I might change up a little bit is this minus a negative again here. Let's just change that to a plus sign. Okay. When you minus a negative, that's the same thing as adding. All right, so now we're going to go through the process we did back in number 2 and figure out what the y-intercept is. So we're going to draw that line straight down here, and we're going to do the same steps as we did back in the last problem. So we're going to use that distributive property, which is going to get us y plus 8. Negative 2 times x is negative 2x. Negative 2 times a negative 5 would be a positive 10. A negative times a negative is a positive. And then we're almost there. Now we just got to get y by itself. So we're going to subtract 8. Since this is a positive 8, that gets y by itself. So we're going to undo that. Over here we still have the negative 2x. And then we have positive 10 minus 8 would leave us with positive 2. So the y-intercept then is positive 2. So find the y-intercept is going to be the point 0, 2, or just 2. And again, that's our y-intercept.